Kiddos. So, Vince, stop looking at pre-calc stuff. Computers away, I don't think we need them out. This lesson is kind of, I would say, a reprieve from all the 500-part problems that we've been having. Alrighty. This lesson is, you're going to recognize some terms that you've used in other classes. So, for instance, we're going to be talking about functions in the form of kx to the a power, where k and a are non-zero constants. A is a power function, and the constant, oh, wait a minute. Yeah, is a power. Okay, there we go. Where a is the power and k is the constant. So k and a are non-zero constants. K and a, or a is a power. So I think that's a typo. It should be a is a power function, or it is a power function. The constant a is your power and k is the constant. This is the word two words that you should recognize. So, y equals kx to the a, where k and a are non-zero constants. That guy is a power function. A is your power. K is either your constant of proportion or constant of variation. Which of those two words have you heard before? Proportion or variation? Both. Have you heard any of them? I know it's been in Algebra 1 when you did direct and indirect variation. Have you heard of any of them in maybe physics or statistics? Yes. So you have used those before. We say f of x varies as the eighth power of x, or that f of x is proportional to the eighth power of x. When you are in college or wherever you're going next, trade school, and you have to do stuff on your own, this is what used to kill me. When you see this, does your brain go blah, 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 blah when it's dummies, variables? I agree. Mine did too. But take a minute and reason it out. If k and a are non-zero constants, what's a constant? Is it a number or a letter? Number. So k and a are non-zero numbers, which means this is an example of something like that. Does that make sense now? Have you seen 3x to the 5th before? Absolutely. They're non-zero, so this could be a negative 7x to the negative 3. So if you take a minute and translate, okay, I know what these words mean, it will help you figure out the dummy general formulas, because those always killed me. All right, so moving on, have you recognized any of those formulas? Yeah, you've used the area of the circle, circumference. Have you used the force of gravity formula in physics yet? No? How about Boyle's law? Somebody recognized Boyle's law?
Yes.
Chemistry. Okay. Again, the combination of combining our curriculums. So, on the other slide, we said that we are going to look at functions in this form. A is the exponent. The guy out front is your constant of variation. What number is pi again?
3.1415.
So, okay, so do you agree in the circumference formula that could have also just been written as like 6.28, right? That's a constant. So the constant of variation in the circumference formula is 2 pi. And R is your variable with no exponent. Does anybody remember what the exponent is? 1. Okay. So the power there is 1. When you used all these formulas, you just used them. You didn't recognize, oh, we had a constant of variation, we have a power. What would the power be in the area of a circle formula, kiddos? 2. And what's the constant? Pi. The constant's the number out front. Now, I will give a bonus point to the first person that gets the power right for this one. I saw Dylan first. -2. He gets it. Vince, were you going to say -2? I might give both of you 1. They were up first. Higher. All righty. Can somebody, Michael, I'll give you a bonus point if you can explain why it's -2.
Because the 2's on the bottom, so you put it on the top.
Yes. The proper form of a negative exponent is to be moved to the denominator. Okay, all 3 of you plus Emily, I owe you 1. In this form, it would be hard to pick out the constant. But in this form, it's easy to see. What's the constant? Okay. All right. In Boyle's law, what is the exponent here, kiddos? Anna? -1. Again, you could also write this as that, and then it would be easy to see what the constant is. So we're talking about f of x varying as the power, and it's proportional to the power. Okay. Do you recognize we could write all of these as a function of the variable? Instead of f equals, we could say f of d. Instead of v equals, we could say v of p. Would you recognize the different forms? Means the same thing. We're going to skip a lot of these notes today, and part of it will come back with warm-ups within the next week, but for our homework purposes, we're allowed to skip some of these. Most of your homework tonight is going to focus on problems like example 1 and 2. If I give you the formula of 1/2 GT squared, talk to your groups, the power is going to be easy to figure out, but the constant of variation may be. So friends, did anybody come up with the power to that guy? Yes, dear? 2. That's easy. Whoa, that's not easy. The power is the exponent. But what do you think the constant is? That's a tough one, Kylie. 1/2 G. How did you know that it was 1/2 G? Vince, why is your computer out?
I was trying to erase some pencils and I was the only place
Oh, did you figure it out?
12 cents.
So each bonus point is 12 cents? In all the years, I've used them for 18 years, no one has calculated the value. That's almost another 12-cent bonus point. What?
Wait, can I cash mine in?
No! Hey!
Can we cash in for money though?
You have money. You get them. Okay. So, Kylie, hold that thought. How did you know it was 1/2 G? Why not just the 1/2? The G is not squared. The exponent is associated with the variable. You got it. Jared, what were you going to say?
No, I mean, I figured you'd given up on her, and I thought I might explain.
Well, do you have a different way? I will never give up on any of you.
Well, no, you just stopped. You just stopped talking about it. That's what.
Do you have anything to add to the way that she and I explained it? No? All right. So the bulk of your homework is translating statements into our power function. Still, I don't think it's going to be anything that's going to rock your brains. Write the statement as a power function. We are using K as the constant of variation. The area of an equilateral triangle varies directly of the square of its sides. See if you can do that. Good morning. Hey. Awesome. Oh, okay, yep, and I'll send them down at the end. Thank you, bye. Vince, at the end of class, go get your binder. Alrighty, so the area, if that's the guy doing the varying, he is by himself. How do I represent the square of the sides if it's represented by S?
Well, I wrote A is equal to KS squared, K being constant, S being the variable.
Absolutely. The square of the length of the sides is S squared. It told you to use a constant. All of these are going to have a constant. The constant goes out in front of your variable. So Jared, you are on target. Now, my key has this. Can anybody tell me what the difference is, or is there a difference?
No.
It just shows like A is a function.
A is a function. Yep, they mean the same thing. So yes, the variable is S. Very, very good. Okay, moving right along. We only have 5 minutes left. I'm going to skip all the graphing parts and get to this. The graphing parts are common sense, but we will take care of a lot of those in warm-ups. But the last 3 problems, I think 3 problems of your homework are real life scenarios. I'm going to give you the formulas, but I want to work one with you. All of these problems require a formula. I am going to give you the formulas. The first step in all of them is to find your constant of variation. Okay, and this is backwards. My dyslexia happening lots of times today. Constant goes first. And then you're going to use your constant, and it might not always be K, but to solve for what you're looking for. So the first step, we have a volume of pressure to be 3.46 liters. The sample of neon gas is 302 degrees Kelvin. That K is Kelvin, so I'm going to put 302.
Don't forget your units.
I know liters and K. I know she would. And the pressure is 0.926. And I'm going to put the units. And remember, these 2 Ks are different. When I solve for my constant of variation, I know you all can work your calculators, you end up with 0.0124 liters over the pressure and Kelvin. You all could solve that. But what I need you to do, the second part says find for me the volume when the temperature is 338 Kelvin. So you're going to put your pressure, 0.0124, with the K, and your new temperature. And then you'll be able to find it. I know,
Last number.
338. I know to put all the units, but for time, I'm quickly moving. Everything cancels out but your liters. Those are going to be the easiest application problems. But no, you've got to find your K first. On the now and later, I have the formulas for you. So if I can switch back, you are to do 12 you can do. Do all of the problems but omit 10 and 11. And these are your formulas. You don't know how